Hello everyone, welcome to this episode. We are now getting started on characters in our visual novel. There's a lot of detail that we're going to be going into, a lot of different things that the characters will be able to do, and several different types of characters that we'll be working with. And we'll talk more about that once we actually start building them here in a minute. Before we get into our characters, there's one thing that you may have noticed I haven't been doing in the past couple videos that let's go ahead and take care of right now. And that was encapsulating some of our scripts into the namespaces. It's so easy to just make a script and not put it in a namespace. But as long as you come back later on and just make sure they're in the right namespaces, then keeps everything organized, keeps code isolated, and that's what we want. So let's go ahead and fix that real quick. So I've got our first scripts here, and if you're using Visual Studio, there's a nice little shortcut. If you Control, Shift, plus, and period, wait, hang on, that's not it. So if you're using Visual Studio, there's a nice little shortcut you can use, and that's hold down Control, then press the plus symbol and the period, and you get a little option here to move to a namespace. It's a little drop-down menu, and then we can just start typing. It'll automatically fill in the closest namespace. Hit OK, and it encapsulates the class inside of that namespace. No hassle. So let's go ahead and go to the other one, Control plus period, and move to namespace. Again, dialog. There we go, another one. And now this one, Control plus period, move to namespace, dialog. Next one is our command manager. I'm going to place this one inside of a commands namespace. But the examples extension, I'm going to encapsulate this inside of the testing namespace. And if you need to, go ahead and make sure you're using the right namespaces inside of your testing scripts too. That way you don't get any compiler errors. We shouldn't have any drastic changes there, but let's just go ahead and play the Unity scene and verify. And indeed, everything's still working, so we are good to proceed. The first thing I'm going to do is I'm going to remove this test object because we're done with that. We're now going to start testing characters. But in order for us to start testing characters, we need to make our characters. And like I said, there are a couple different kinds that we'll have inside the visual novel. So let's quickly go over what types of characters we'll support. First off, there's a text character. And a text character is simply for rendering dialogue on screen and for saving variables that would be related to that character, such as maybe name font, name color. You can configure them, but they won't actually have any art assets. So this would be for like your generic characters who may speak on screen, but you don't show anything for them. So maybe like a large crowd or some random guy on the street. But then you've got sprite characters, and sprite characters will be basically what we're using here, your traditional flat visual novel character that uses a sprite or layers of sprites on top of each other. And this will also be a sprite sheet character, and the difference between a sprite and a sprite sheet character is obviously what it sounds like. So a sprite character just uses sprites as their own images, whereas a sprite sheet character has all those images amalgamated together into one large file that you split up into multiple sprites. So then after that, we've got Live2D characters, and those will be animated on screen. And of course, we'll end it off with 3D characters, which will have their models appear on screen. So these are the different types we're going to make, and we're just going to focus on text characters right now. We're going to move through these guys one episode at a time, and we'll keep it small here. Let's start with the very basic and start working with text characters. So I'm going to come inside of root, inside the main canvas, and the layers, and the characters, and just go ahead and delete that character there. We're not going to be working with any graphics now, so we'll have a blank character panel. And now, inside of our core, we need to make the scripts that are going to control our characters. So let's create a new folder and just call this characters. Inside of there, we'll make one script, which is going to be simply called character. Now this is going to be the base class from which all other character types derive from. In addition to that, we're going to need a system that will manage our characters for creating them and retrieving them when we want to get a certain character by a name. And this is going to be simply our character manager. So we'll make another script for that as well. Let's start off by opening our character manager up and configuring a couple things there. We're going to encapsulate this inside of a new namespace, which will be for our characters. And we can remove start and update here. And what we're going to make instead is a void for awake. And we're going to make this a singleton by giving it an instance. And inside of awake, we'll simply assign the instance. There should only be one of these in the scene, and they won't persist through different scenes. So setting it like this will be fine. If you do plan for your character manager to persist through scenes, just make sure that you run a check to see if there's already an instance, and delete it if there is, or delete this new one if there's already an instance. That way, you don't pile them on top of each other and mess up your logic. And now, to keep track of all the characters that are going to be instantiated in this scene, we're going to want a dictionary, so that way we can look them up and provide them whenever we want to get a specific character. But we'll make this private, and we'll just access those characters through different functions. Add a string for the character name, and then the type as the character, and call this the characters. So whenever we create a character, this will just give us a nice lookup table. So now let's go ahead and define what should be in a character. If we open up the character class, let's get rid of start and update, and let's also get rid of mono behavior. It's not going to be attached to any game object, and we'll just encapsulate this within the character's namespace. Now, as I said, this is going to serve as the base class for every different character type we make. So we're not actually going to have a character that is simply a character type, but maybe one that's a text character or a sprite character. So we can make this class abstract. That way, any character we make has to be of a type that inherits from this class, not this class itself. And we want two variables for right now to keep track of, one of which is going to be the name of the character. We need to know who this character is, and we also want to keep track of the root object that has been spawned for this character in the scene. And that's going to be represented as a rect transform, which will be on the UI, and it'll give us nice control over the position, the size, and whatever else we want to change about that particular character. We'll call that our root, and by default, we'll set that to equal null. Okay, so we've got the start for our character here. We know every character is going to have a name, and they're going to have a root. But they're also going to have some additional information that will be possibly unique to each character. And we'll refer to this as our configuration data for the character. So the goal here is for every character that we want to appear on screen, each one that you know is going to appear in your visual novel, maybe you'll want to customize characters with their own sort of colors and their own fonts to give them unique looks, maybe different graphics for the dialog box when they speak. And we'll do this through a character configuration file, a scriptable object which will hold all of the data for each character that can be possibly instantiated into our scene. And one of the values that this configuration data is going to hold is the type of character that should be created whenever we call for one to be made. So if I have a character named Stella, and I want her to be a sprite character, I'll make a configuration for her, give it her name, give it her dialogue and name color, give it her fonts, and give her a type of sprite. So anytime I want to create that character, I just look up the configuration, I can see everything I need for her, I can see what type, and then I can create the appropriate instance and the appropriate character class for that given character. So this is going to be requiring us to make another script, which will be our scriptable object to contain that data. But let's go ahead and define the different character types that we can have in here, and we'll just apply that to the configuration when we make it. We're going to reference this as an enumeration, and we'll call this our character type. These are all the different types of character that this system will support. The first of which I said was going to be a text character, which has no graphics on screen and is just used for dialogue. And then we'll have a sprite character, which uses textures as sprites, and then a sprite sheet character, which has multiple sprites per texture. And then we'll have our Live2D character and our 3D model. We'll call that model 3D. So these are all the different types. And rather than assigning this variable to the character itself, because this class is going to be instantiated on a per character basis, we're going to define this inside of the configuration file. And creating the configuration file will be pretty easy. Let's come right straight into main here, actually into our scripts, because it is going to be in scripts, in core. I guess I could have stayed here, but I like to be difficult every now and then. Let's open a new folder, and we'll call this Scriptable Objects. Inside of here, I'm going to make a new C# script, and we will call this our character config SO. SO meaning scriptable object, just so we have some sort of standard naming convention for this. This is going to be the scriptable asset that will contain all of the configuration data for each character that can be instantiated in our project. So let's open that up. Inside of here, let's go ahead and add that to our character namespace. And let's remove start and update and replace monoBehavior with scriptable object. And the scriptable object is going to be something that we can create as its own asset and then configure inside of the Unity editor. But in order for us to make a file of this type, we need to give ourselves a menu where we can actually create it at. And Unity has a nice header attribute called create asset menu that can do just that. And all we have to do is specify a file name and a menu name. And the menu name is going to be within the context menu of our right click that we'll navigate to in order to create this asset. So let's say menu name equals, and then provide the path that we would like. I'm going to say this will be our dialog system. That's going to be the start, and it's going to be under a button called character configuration asset. And when we create this, it's going to need a default file name. So right before menu name, let's go ahead and add in file name, then a comma to separate the two, and any new one I just want to call character configuration asset. And so in Unity, what that officially does for us, if you click in empty space in your project here and go to create, then find that path that you defined, and then here's the button to create our asset. If we click that, we now have a scriptable object asset, which we can populate with the data that we want. But let's go ahead and delete that because that's not the place I'm going to put it, and let's add the information that we need inside of this configuration file. We know that this file is going to contain data for every character, which means we're going to be using a list or an array to hold all of this data. But we need to define that data first. For organization, let's put this in a new script. Let's come to the characters, create C# script, and we're going to call this character config data. Open that class up, remove monoBehavior, remove start and update, and encapsulate in that namespace. And this is where we're going to define all the information that we want to configure for every character. The first thing, obviously, is we need to be able to look up the data, and that will require having a name for the character. So we'll make a public string for the name, and we're going to want the type of character. We can make this of that character type that we made, and since that was under the character class, we'll reference it under that class and call this character type. In addition to the name, I might want something to help me write my dialogue files a little easier, such as if I have a character with a long name, maybe like the Constipated Warlord, then having to type that out every single line is not going to do me any favors, and I'm probably going to bang my head against a wall. So why don't we make an alias, which will essentially be a shorthand way of writing a character name that will equally translate into their real name and grab their configuration data just the same. We'll make another string just for that purpose, and we'll call that the alias of the character. Next, let's go ahead and define some unique customizations for them. So we'll make a color for the name color. This will be the color for the name text whenever they speak, and a public color for the dialogue color as well. And now let's also define maybe what kind of font they can use. And for TextMesh Pro, this is going to be the TMP font asset type. So we'll say public TMP font asset. Make sure you include the TM Pro namespace, and we'll call that name font. Let's do the same thing for the dialogue font. That's the data we're going to be saving, so we can hop back into our scriptable object, and now make an array that holds the character configuration data. Make it an array, and we're going to call this our characters. But let's make sure that it is public And in order for this to be seen inside of the inspector, we also need to make sure that our class is serializable with the system.serializable header attribute. And now, hopping back into Unity, now we can make our asset and just make a few quick configurations. Let's actually put these inside of the main folder, inside of another subfolder, which I'm going to call configuration. This will hold different scriptable objects that we'll make later on, including a file to configure how the dialog system runs and some of the default settings that it uses. Inside of here, if we right-click, create, go to dialog system, and character configuration asset, right-click that, and default name is fine. If we select this, then we have our character array here, which is empty at the moment. So let's go ahead and add one, and we get element 0 here. Nice thing is if we have the string at the very top of a serializable element like this, then when you change the name, it actually changes what displays as the element title, which is very handy. So the character that I'm going to start with is obviously Stella, my mascot. And the alias is simply going to be S. Now, when you make an alias for a character, obviously make it something that's easy to interpret what that means, something unique for that character. But S is going to be fine, and this would actually be a sprite character, which we're not going to work with in this system yet, or in this episode, but I am going to set her text temporarily to white, and her name font, we only have these two fonts, so we'll select the first one. We'll add fonts later. And I'm also going to make a just regular text color, which I will call Ellen, like so. And maybe another text character, which I'm going to call Benjamin. And I'll call him Ben for short. Let's say maybe Ellen is going to use some kind of pinkish color for her name. And for her dialogue, it's going to be a little orange. I am not a color guru, so that's probably going to be hideous, but it'll prove a point for showing the customizations at least. And Benjamin will be kind of greenish and a cyan color for the dialogue there. So they've got their own colors. They're using the same font right now, but let's go ahead and continue on. For us to really make use of anything related to characters, we need to be able to create a character. We'll run this straight through our character manager, but we're going to need to know what character to create. So, and for that matter, how we're going to create them. So let's make a function that'll handle the creation of any character that we pass in. We're going to make a function called createCharacter, but we're going to have it return the character class. So no matter what type of character we create, we're going to get an instance for them of this character type. We'll just call this createCharacter, and inside of here, we'll just say the name of the character that we want to create. And then the system will look at that name, check the configuration file, and figure out what to do from there. Of course, we only want to create the character if we don't already have one in our array there. So we'll do a quick check. If characters.contains key, character name to lower, the case shouldn't matter for the name. If it already contains a key, then we want to log a message and let ourselves know that, hey, this is a duplicate character we're trying to make, and fix our spelling or whatever it is we're doing. And we will return nothing. On the other hand, if it does not contain the key, then we're going to reach this portion of code, and we should go ahead and try to create them. So we don't actually have a way to create a character. This class is abstract, so we can't instantiate a new version of a character. So we need to make a new type of character, and then instantiate that type, based on whatever we pull from the configuration data. For right now, let's return null to satisfy the return requirements, and head back into Unity. So now comes the part where we need to define our different character types. Inside of the characters folder, let's make another subfolder called character types. And in here, we'll just make a script for each type of character that we specified in the enumeration. So our first one is going to be a text character. Start with character, then underscore, followed by text. This class will represent our text characters. And we'll do the same thing for the sprite character. And we're not going to make a sprite sheet character because sprite and sprite sheet will be the same kind of character. They'll just operate a little differently logically inside of that same class. But we still need one for Live2D, as well as the 3D model. For each of these, I'm going to do the same thing. I'm going to remove start and update because we don't need that. I'm going to move them inside of the character namespace. And I'm also going to change mono behavior to that character class. So now we are making it inherit from this class, and character text is officially a character type. We're not going to be working with these today, so we'll go ahead and close them out and just work on our text character. So we have many different types of characters, but we want to be able to create them the same way, which is call a create method straight from this character class from which they all derive. And the way we can do that is by just making the constructor within the character class, and each of them inherit from it, and we can just change it from there in each particular class to make it unique to their own type. But the process is going to be really simple. We just make a new constructor with public character, and figure out how we want to create the character and what we want to do with it. So at this point when we're creating the character, I'm going to assume that we already know the name of that character. So let's go ahead and say that we are passing in a string for the name of the character. And we can simply say this.name equals the name that has been passed in. And so whenever we create a new character, we're going to pass in the name of it, and that will get assigned, no matter what type, whether it's text, sprite, Live2D, what have you. But if we look back at our character text here, it's underlined with an issue, and it's saying that there's no argument given that corresponds to the formal parameter name of character string. And this is basically saying that because character is an abstract class, the class that inherits from it, text here, must provide its own constructor that is similar to the base constructor. In other words, it needs to have its own implementation for being created. We're going to make this quite simple, and we're just going to call that same logic that was referenced in the character class here. So we still want to assign this.name, but we're going to not necessarily call it by defining that line again. We're just going to call it by referencing the base constructor. We'll do that by first making our own constructor, character text here, and we'll require the same format, the same parameters, so a string for our name, and then after a colon, we'll specify base followed by the name. And what this means is whenever we call this constructor, we're also calling the base constructor, which inherently assigns the name of the character we're creating. So then I can simply add on to that, and maybe I'll show us that we are actually creating a text character through a debug statement. Just like that. So whenever I create a text character, it's going to show me that I have created a text character, and the name will be assigned to this instance. But that also means if you look in Unity, we get an error for each one of those other classes, so we just need to make sure that we provide a constructor there as well. And like that, now we have a basic way of creating each character type. This is not the extent of it, but this will get us started for the moment. Now, if we come back to our character manager in the create character function, now we can go ahead and gather the information that we want in order to create this character. Now, that's going to require us referencing the character configuration asset. And we could add that up here, just in one of our variables, and assign that from the inspector, and that'd be simple enough, but I'd rather place this in a central location that'll be something we can change and edit with all the other default options for the whole project. And this would be more like the configuration settings for the dialog system. Now, if you're thinking anything like I am, that sounds like another scriptable object. Since this is going to be data that's universal to the project, and it's going to be for multiple values referenced by multiple sources, it only makes sense to store all of that inside of a scriptable object. So that's exactly what we're going to do. Let's come to scriptable objects, and let's make another script, which will be the dialog system configuration SO. And I know I misspelled something there. Dialog, no I did not. Okay, that's surprising. Let's make that a scriptable object, and then just encapsulate this within the namespace of dialog. And this is going to hold the character configuration asset that we made earlier. So we'll have this configuration file that'll basically be referenced by the dialog system, and we just go here anytime we want to change any default variables, maybe like text speed or default text, default colors, default fonts, what have you. And one of those assets will be the default character configuration asset, which of course you could swap out with different ones if you wanted to, but this will give us a nice spot to load everything from. Let's make a asset menu so that way we can actually create this configuration file. The default file name is just going to be dialog system configuration. And the menu that it's going to be under is going to be dialog system, just like we did for our character asset. Only what this is going to be called is the dialog configuration asset. And I'll remove those namespaces I'm not using, but there is a namespace I'm going to need, and that is the characters namespace, because I need reference to the scriptable object for the character configurations. So we'll make ourselves a public character config SO variable and call this the character configuration asset, which means in Unity we should be able to come to our configuration folder, right click, create a dialog system. There's our configuration asset, and inside of here we have a reference to a character configuration object, and that will be the one that we created earlier. So we'll drag that in, or you could select it from that menu since it's the only one, and that will give us a reference to whatever configuration we want to use for the characters. But that just means that we need to assign this object to something. Why not make that our dialog system, since it is the configuration after all? So let's open up the dialog system, and right above everything else, let's give ourselves a public dialog system configuration SO, and just call that config. But this is probably not something that we want anything to edit, and we won't be able to use a private setter here because it won't serialize in the inspector, so we'll just have to reference a private reference to the object and then point this to that reference. So we'll make a private dialog configuration SO underscore config, and then for this public config we're going to point that to the private version. So all we can do is retrieve the config publicly and then assign this one from the inspector by serializing that private field. And so that gives us a field here for the configuration asset that we can use to control our dialog system. Let's go ahead and put the only one that we've created in that field, and now we've got a small little configuration for it which can point something else, i.e. our character manager, to the currently configured character configuration asset, the one that we've selected for this dialog config. And so that can, by referencing the dialog system, our character manager will be able to look at the configuration and then see what kind of configuration has been applied for all the characters, depending on whatever asset we've assigned to this script here. Ready for a break yet? Because I feel like I am. Okay, so we are returning null right now, but we're going to need to grab a character. In order for us to know what kind of character we need to create, we need to take a look at the config and see if there's a matching character to what we're trying to create here. If there is, we need to see what type they are, and then make the appropriate type based on whatever's given to them. And you know, if we don't find a character by this name within the configuration, well then we just need to return some kind of default character, which would be, we would assume, a regular text character. If they don't exist in the configuration asset, then they probably don't exist with any art that's been given in the scene or any prefab, so it would just be a default text character. In order for us to do that, though, we need to evaluate this name against the configuration and get some information on the character that we're trying to create. So at this point, before we return null, we know that our list currently does not have any character by this name in it. So we're safe to proceed, and we just need to go ahead and get the information for this character. The information that we gather is going to be used to not only create the proper character class, but also to give the data that it's going to need, such as what prefab the character might need to use, what directory their art assets are in, and what configuration file they're using, what configuration data that they're using. So all of this is going to be stored inside of a private class, which we'll call character info. Inside of here, for the character info, we're going to want whatever the name is of the character that we're creating. By default, that will be nothing. Since we're just working with text characters, we're not going to worry about a prefab or a directory for art right now. We're only going to add the one thing that matters for all characters, and that's going to be whatever configuration data they're using. So we call that the character config data, and we'll simply call that config, and by default set it to null. So we need to gather this information to generate the appropriate character. Let's make a function to do that for us. Be private get character info by the character name that we have supplied. And now let's go ahead and make ourselves a character info reference, but this has to be the capital character info. We'll just call this info and set that equal to whatever we retrieve from get character info, passing in our character name. And my mistake, I used the wrong thing there. That's the name of the function, but we also need the return type of character info. There we go. So how are we going to get this information? First of all, we need something to store it in. So let's make ourselves a new character info class. Call this the result equal to a new version of our character info, a new instance of it. At the very end, we're going to return whatever our result is, but inside of here, we can go ahead and say that result.name equals whatever the character name is we're passing in. And now we need to get the configuration. And the best way to do that is to reach out to our configuration file and find what suits this character name. If we have anything applied in there, it'll return the config. If not, we should create a default one. Let's create the capability within our scriptable object to return or to search for a character and return the configuration if one is found. This will be a public return type of character config data, and we'll call it get config, taking in a string for the character name. And since we're only comparing character names with case insensitivity, we need to make sure that what we're checking here is not case sensitive by converting it to lowercase. And now we simply loop through all the characters that we have and find the right one. So we'll compare the name of the character we're looking for to the name that's configured within this data using string.equals and find out if there's a match. We're using string.equals because there is a slight optimization compared to just string-to-string checking, and for just a couple other reasons which we won't really get into right now. But if string.equals, let's check the character name to the data.name.toLower. So if it equals that current name, or remember, we've also got an alias for the character name to make things easier for us. If string.equals character name to data.alias.toLower, then we know that we have a match and we can return the data. But that's not exactly the safest way to do that. And the reason being is we don't want to return the value that is directly defined within the scriptable object. The reason for that is the persistence of scriptable object data. So Inside of the game, when you export it, every time you reset, the scriptable object is going to reset itself. That's not the same for when you're in the editor. When you're in the editor, if you make changes to a scriptable object value, then even when you close out of the editor or close out of the game, it's not going to revert back to what it was because you're changing the original data. So what we want to do is return a copy instead of the original value. That way we're preserving the original data in its proper form. So we'll create a copy by referencing our character configuration data and just making a function called copy. Inside of copy, let's make a new return value. Return the result. And in between that operation, let's go ahead and populate it with some data. So result.name equals name. Result.alias equals alias. Because we're just making a copy here. And the character type is going to be the same as well. So result.character type equals character type. And we could say that the result dot name text or name font rather is equal to name font, and result dot dialog font equals dialog font. But where we change up is when we copy the color. We can't reference the original color, and by saying result dot name color equals name color, because color is actually going to reference the original value again. So we need to create a new color. Let's duplicate that line and do the same thing for the dialog color. There, and so we create a copy. So in config SO, instead of returning data, we'll return data.copy. And now we are safely preserving the original data while also fetching whatever is configured for that particular character. Now, if we don't find a configuration, we also need to return some kind of default value. And this needs to be something specifically defined within the character data class as well, but it's going to reference our dialog configuration, which we'll configure with some default values for text color and text font. Back in the config data, let's make one more, but this is not going to be tied to an instance. It's going to be static, straight tied to the class. So public static character config data, and we will call this default. Inside of here, all we're going to do is retrieve a value. So we'll have a getter, and we'll kind of do the same thing we did here. Just copy all of that, paste it in there. But in here, we're going to replace these fields with something else. So name is just going to be blank, and the alias is going to be blank as well. The character type, if we didn't find any match, we can just assume that the character type is going to be of the type text. It's safe to assume that, and we need to get the default name font and default name color as well. So if we come to the dialog configuration SO, we have our character configurations asset, but let's also go ahead and define the default color and default font for the name and dialog text. We'll reference the color with a public color and say default text color. And then some kind of font. So public TMP font asset, use the TM Pro namespace, and call this the default font. And so in the config data, let's go ahead and make a variable to point to those values. So private static color default color is going to point to the dialog system dot instance dot config dot default text color. Likewise for our TMP font asset, the default font is going to be default font from that configuration. So our name font will be default font, same with dialog, and the default color is going to be applied here. And so when we try to get the configuration, if we don't find a match, then we'll just return character config data dot default. Default should be is it data? Did I do data? I sure did. I meant to put default there. Okay, so that should be default. Okay, so we'll either get the match or we'll just return the default value as defined in configuration. Speaking of the configuration, let's go ahead and define what that is. We've got plain old white for the default text color. We'll leave that as it is. And we'll just set the default to Liberation Sans for the font. And finally, we can head back to our character manager where we're getting the info and set result.config to hold all of that data to equal the dialog. Actually, since we'll reference the configuration possibly multiple times here, let's make a pointer instead. So private character config so, we'll call this config and point that to the dialog system, which means we need the dialog namespace dot instance dot config dot character configuration asset. And we say config equals config dot get config for our character name. And then we return the result. So now when we're trying to create the character, we fetch the info, which has the name and the configuration, and now we can figure out what type of character we need to create. It's been a whole lot of scripting and not a whole lot of testing or verification, so I want to pause for a minute and make ourselves a new test script so we can see where we're at right now and what's going on behind the scenes. Let's make a new C# script and call this test characters. Of course, the system isn't finished, but it's a good idea to check our progress right now because we've been going for about 40 minutes here without testing it, which is not necessarily the safest thing in the world. So I want to just pause and take a moment to do just that. So let's go ahead and try to create a character. So we'll use the character namespace. And now we should have access to the character manager. Okay, so let's go ahead and say a character equals character manager dot instance dot create character, and we're going to check for Stella because she is configured and our function isn't actually doing anything great right now. If we look back at character manager, we're still returning null, so we're not getting any kind of value. So we won't be able to test that unless we go ahead and do a test within Visual Studio, a debug test. I don't know how it is for whatever coding application you're using, but for Visual Studio, up at the top, we've got this attach to Unity button. And if we just change this to attach to Unity and play, then whenever we click this button, it's going to automatically start a debug test and start the Unity game. But for us to debug something, we need to set a breakpoint. That way, whenever it reaches that line of code, it's going to stop, take us back into the script editor, and show us what kind of data we've gotten. So I want to see what happens when we get our result. When we return the result, I want to check what's in that result. So I'll click on the side over here, which sets a breakpoint. So once the game reaches this point in code, it's going to bring us here and we can check what's been assigned. This is just going to require us to do two things. Inside of testing, create an empty, which we'll call character testing, and give it the test character script, as well as make a new manager, which is going to handle our characters. And assign this the character manager script. And that's it. So now we should be able to play and check out what happens. Come back into Visual Studio and now attach to Unity and play. Okay, so now I can see this line is highlighted gold, so it has reached this point. So if I just highlight over here, we can see that it has populated with a new character. So what's in character? Okay, some character with the name of Stella. We can see it did create the character name, but the real magic is inside of config. What do we have? We have S alias, that's correct alias, and we have the character type of Sprite. Cool, so it looks like it's fetching everything just right. To stop the test, let's go ahead and come up to this red stop button here, click that, and we're done. Next thing I want to check is Ellen, because she has some different colors here, and we should be able to see that. And that just requires us changing Stella to Ellen, and then trying it again. Attach to Unity and play. So we're rolling, it's running, and does not look like anything has happened. Okay, so I just need to reload by going into Unity and letting everything compile. And now we have hit this, so what's our result now? We have Ellen, the configuration, and yes, indeed, the colors are different. We've got Ellen, the alias E, so we can see that it is fetching the right configuration, which means we are safe to proceed from here. I'll go ahead and remove the breakpoint because we've already evaluated that that is working. And now that we've got the information, now that we know what type of character they are, we can go ahead and create the appropriate type for the character. This is going to require us making another function to return that data type. So let's make a private, just return the character type, and we're going to call this create character from info. So we're going to use the character info in order to process this and return an appropriate character instance. Alright, so here's how this is going to go. We're going to go ahead and simplify things because we want to access the configuration from inside of this info class. Because inside of the configuration is obviously defined our character type. So we'll just make it easier on ourselves by saying character config data. Call that config, that way we don't have to say info.config every single time. And just type this in info.config. So let's check and see what kind of character we've got. Let's check if our config.character type equals the character type.text, then we know that we need to return a new character text and provide the info.name for the name of the character. Easy. Let's go ahead and set up the other ones, even though we're not focusing on them in this video. Just go ahead and have it in place. If character type equals sprite, but we also said that sprite sheet is the same kind. So, or if our configuration.character type equals the sprite sheet character, then we'll return a character sprite. Same thing with Live2D, just character Live2D, and the 3D, or the model 3D for character model 3D. If it doesn't match any of those types, which it should, then just return null. We could do an else here, but in case we want to add more types, I'll just leave it as that, the way it is. So no matter what our type is, we're going to go ahead and create the right kind, and then return it as the base character class. So that way, no matter what the character is, we can go ahead and get them as an instance, and then do something with them. So after we get the character info, let's go ahead and make the character, and set that to create character from info, and just pass in the information that we retrieve from the character, and return whatever character was created. Meaning now in our test characters function, this should return us a legitimate character. So we should be able to see the message that's created for whatever character we created. Inside of character text, whenever we construct it, we get the default message created text character, and the same is true for sprite and whatever else. They just have their own little log statement. So let's go ahead and just duplicate that a couple times. We know that we'll call her Ellen, and then we'll call this one Stella, and say create Stella, and then create someone who doesn't exist. We'll say Adam, create Adam, so Adam should return a text character. So when we hit play, we come into console, and yes, we can see it's working. For Ellen, it matched her configuration, found that she was a text character, and so we created a text character. For Stella, it matched her configuration, found she was sprite, and so we created a sprite character. And the same thing for Adam. He wasn't defined in here, so it just defaulted him to a text character. And so that's all we need to really start creating our characters. We've got the base system in place. We can check them. Oh, But there is one thing we forgot. After Character Manager, after we return this character, we need to make sure that we go ahead and log them right into the dictionary, so that way we can't create the same character twice. So real quickly, after the end of all that, we'll say characters.add character name to lower, followed by our character. So then one more test characters. We're going to try to create Stella twice, call her Stella 2, and see what happens. As expected, all the characters are created normally, but it refuses to create the second instance of Stella because she already exists. Perfect. So that was quite a bit covered in this video, but now we have the base system in place to where we can create and spawn all of our different characters no matter what type they are, and configure them however we want to within the configuration of the dialogue system. So we're going to end off here, and in the next video, we'll pick up with some smaller topics on how to give some features to our text characters and characters as a whole. So thank you for watching, and I'll see you in the next one.